All right, last video, unless your instructors reorganized these, but when I did the videos initially, this would be the last one. And it's the law of cosines. We've saved the best for last. Again, law of cosines allows us to deal with um, oblique triangles. And it allows us to deal things that don't have the law of sine in them, or that I can't use the law of sine with. So what the law of cosine says, similar to, you remember the law of sines, its formula was A over sine A is equal to B over sine B. That was our formula. In the law of cosines, we have similar formulas, and here they are. Now they look a little bit unwieldy at the start, but if you look at them, there's a pattern to each of them. So you have the side a squared is equal to b squared plus c squared minus 2, and then these two letters are the same as those two. And then it's always taking the cosine of the angle from the side that you started with. So if you look at those, for a minute or so, you'd probably be able to write them down without even looking at them again. However, your instructor probably will give you a formula sheet. But say I wanted to know b squared, the formula for b squared. It would be a squared plus c squared, that's the other two letters, minus 2, and I have to use these two letters again, 2 times a times c, times the cosine of whatever angle corresponds with that side. There's the the formula that corresponds with b squared. So the formula allows us to deal with questions where I can't use the law of sines. And essentially, it's a question where, like the law of sines, if I have a triangle, if I know a side and I know its angle, if I know those two pieces of information, I'm going to use the law of sines. If I don't have a side and its angle, then I'm sort of stuck using one of the law of cosines. Well, the laws of cosines aren't, they're just plugging numbers into a formula. A couple of things you have to watch, but for the most part, they're just plugging numbers into a formula. Let's try a couple. Solve triangle ABC. If A is 32, okay, let's write these in. Angle B is 125.2 degrees. And so this is angle B, so this has to be side B. And then side A is 32, side C is 48. 32 looks like this is the shorter one. We'll call this one side A, so that makes this angle A. And then this would be side C, making that angle C. Side A, they say, is 32, and side C, they say, is 48. Let's write all this stuff over here. So 32, angle A, I don't know. Side B, I don't know. But I know angle B is 125.2 degrees. And then side C is 48. So notice that I don't know any side and its corresponding angle. If that's the situation that you're stuck with, then you're using law of cosines. If you do know a side and its angle, use the law of sines. Okay, so how do I go about this? Well, I guess I have to pick a side that I want to find. If I know this angle, it makes sense that I go after that side there. So let's use the formula that is searching for b. Okay, so b squared is equal to a squared plus c squared minus, I just practiced this one, cos b. Okay, now we'll plug some numbers in. Okay, so b squared, I don't know b, so b squared is equal to a squared, so it's 32 squared, I should have that in brackets, plus c squared, that's 48 squared, minus 2 times a times c times the cosine of b, which is 125.2 degrees. Now, when I first started teaching this, I'd have students do each little portion at once and then combine things all together in the end. But I've since, with the newer calculators, what you can do is you can just plug all this stuff into your calculator right off the bat, and you should be okay. So let me try that. if my calculator will behave. All right, so 32 squared plus 48 squared minus 2 times 32 times 48 times the cosine of 125.2. Close my bracket, go. Oh, it gave me a big number. It's huge. 5,098.8. Oh, but this is b squared, so I have to use my square root property, right? So I have to square root that. Where's my square root button? Oh, right there. Square root of my answer. Yep, go. 71.4. So B turns out to be 71.4 feet or meters or whatever it is. Let's go up there and put that in. 71.4. Now, since I have a side and its angle, I can now use the law of sines to complete and figure out what the last angle is, or what the angle A is and what angle C is. And I'll let you do that. Maybe you might want to pause the video and go to your textbook and try some of these first questions where you're using the law of cosines and you're looking for one of the sides. That's what we do first. Okay, when you're ready, hit play again, and let's try a similar kind of question, but this time we're not looking for a side, we're looking for an angle. So they say solve RST if R is 3.5, S is 4.7, and T is 2.8. This one looks to be the smallest one, I'll call it 2.8. This is the longest one, we'll call it 4.7, and this is 3.5. So if this is R, this is angle R. If this is T, then this over here is angle T. And 4.7, if that's S, that means this is angle S. Okay, so I guess I don't have A, B, and C here at all, do I? I have R, S, and T. Let's change those. R, S, and T. R, S, and T. Okay, little r is 3.5, little s 4.7, and little t 2.8. And so what's missing are the three angles. Okay, so I can use the law of cosines to help me solve that. Okay, so let's pick any angle that I want to find. Let's say, I don't know, R looks pretty. Let's do R. Let's see if we can figure that angle out. It looks to be fairly small, hey? I'm probably judging less than 45, but I don't know. We'll see. Okay, so if I'm looking for R, I'm going to go R squared is equal to S squared plus T squared minus 2ST cos R. Okay, I'm just following that same format that I have with the law of cosines. I'm looking for cos R, so the only one that I could use would be the one that has R to start with. Okay, similar with this one, we'll plug our numbers in. So we know most of these numbers. R is 3.5 squared, S 4.7 squared plus T 2.8 squared minus 2 times 4.7 times 2.8 times the cos of, I don't know the angle. Okay, so on the last one I was able to just plug it all in my machine and it worked out beautifully. This one it looks like I'm going to have to do a little bit of work. Well, maybe I could do this. Let's move these two terms to the left side. So let's go 3.5 squared minus 4.7 squared minus 2.8 squared is equal to a negative 2 times 4.7 times 2.8 times the cos of R. Let me move your turn, oops, out somewhere. Okay, now I want to isolate this term here, so I'm going to divide both sides by what's in front of it. So I'll have 3.5 squared minus 4.7 squared minus 2.8 squared all over minus 2 times 4.7 times 2.8 is equal to cos r. Oh, that's a whole lot of moving things around. Not hard moving, but it's been moving around. Okay, let's do this on our calculator. When you do this on your machine, make sure that you put brackets here and here and there and there. If you don't, wild things are going to happen. Okay? Okay, I'll break out my machine and do it. Okay, so bracket 3.5 squared minus 4.7 squared minus 2.8 squared. Okay, now I got to do a bracket. Bracket. Divide, put another bracket, minus 2 times 4.7 times 2.8 bracket. Go. Ah, gave me a good answer, I think. The answer it came out to was 0.6717. And I actually like to write down with these trig ones, where I'm going to have to do an arc cos, I like to write that whole number in, or as much as I can, just to help me with a little bit of accuracy. So that whole mess came out to 0.671733, etc. Now I want to solve for r, and so if I want to get rid of the cos here, on the other side it'll become the arc cos. So the arc cos of 0.671733. Okay, so let me do that. Arc cos of what I just got equals 47.8. So R will be equal to 47.8 degrees. Let me go up there and put that in. What was it again? 47.8. R was 47.8 degrees. Okay, so I've solved for R. Now, since I know a side and its angle, I could then use the law of sines now to find S, and then subtract them from 180 to find out what t is. So that gives you an idea of how you can use the law of cosines to help solve a question in which you don't know a side and its corresponding angle. But the law of sines and the law of cosines both help us solve oblique triangles where I don't have a 90 degree, and therefore I can't use my sine, cos, tan, or Pythagoras. All right, try some of those questions in your text or in your handout. And as always, if you have any questions, give your instructor a call.